Section 11.2 series. So what is a series and how do we compute a series? How do we say that the series is convergent or divergent? And it is related a little bit to the sequence. So in the last video, we saw what a sequence is. Remember, a sequence is a list of numbers, so something like A1, A2, A3, and so on. What happens if we add these numbers? So if we add all these numbers, A1 plus A2 plus A3 and so on, this becomes what we call a series. So basically a series is an infinite addition of numbers. And the notation for the series is this. So instead of that bracket or braces, we are using this summation notation because it's a sum. So in general, this is the general notation, summation of a sub n is going from 0 to infinity, or n could be going from 1 to infinity, or n could be going from any number to infinity. But if we are using n is equal to 0 to infinity, then the first term will be a sub 0, next will be a sub 1, a sub 2, and so on. So that is what the series this notation means, the summation. Sometimes we can just have like this notation and no limits. These are called limits. So this is the lower limit or the starting. This is where we start, and there is where we are going. Okay, the infinity thing. So now what happens is that sometimes we don't put anything down here and up here, but still it means it will mean we are starting at 1. So a1 plus a2 plus so on. And it's going to infinity. So one of the examples here, if we have summation 1 over n is equal to 5 to infinity. So which means our first term is when we plug in n is equal to 5. So this is where we will start. So now we want to talk about convergence and divergence of series. So sometimes these series, although they look like, okay, we are keeping on adding numbers, so how is it possible that a series can converge or it can go to a certain value? It looks like if we keep adding stuff, it should go to infinity eventually, but you will notice that sometimes it goes to a specific number. And how do we find that? Well, there are different ways to check, and that's what we are going to start. And there are a bunch of ways and bunch of different conditions. The basic thing or the basic technique is to consider something we call finite sums. So remember, the series is an infinite sum, but now we are going to look at finite sums. So what do we mean by finite sums? Like a sum of finite number of terms. So for example, and we have some symbols for these sums. So when we are talking about just the sum of the first, basically just the first term, we are calling that sum as sub 0. When we have the sum of the first and the second term, we are calling it the S sub 1, and so on. S sub 2 and S sub 3 will be A0 plus A1 plus A2 plus A3, and so on. So that S sub n, like the sum of n first n terms, so it will be A sub 0 plus A sub 1 plus A sub 2 plus A sub 3 plus dot 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 plus A sub n. So this can be written in compact notation like this, that limit of ai when I is going from 0 to n. By the way, over here we used this letter n, but it's not necessarily n. It's just an index or a kind of a variable. So if you instead use a sub I is equal to 0 to n, or if you say a sub k is going from 0 to n, it is the same, 0 to infinity, sorry. So then these are the same things, it will be the same sequence. So the name of the index or this is basically called index. It's what you choose is your choice. And so because we are using the n up here, so it doesn't make makes sense to put n here, because if I put n here, then I'm kind of saying n is going from 0 to n. That doesn't make any sense. So that's why we need to either change this value, or we have to change the value of these. So either we can say summation of a sub n when n is going from 0 to k, or I can say summation of a sub k when k goes to 0 to n. So how do we find the limit? Okay, and that's what we are looking at. So first we found the finite sum, which means sum of finite terms. And what we are going to do now is we are going to let n go to infinity. Okay, so if n goes to infinity, then this can be written like this. But what is this? This is our series. So if you recall, we can compare it with the improper integral. If you recall the improper integral, something like this, 1 to infinity f of x dx. Remember, we would write it like limit as t goes to 0 of the integral from 1 to t f of x dx. So this notation is something similar. So to find the integral, this improper integral from 1 to t as t goes to infinity, so we will be using kind of same thing with this series. We are summing from 1 to n, and then we are letting n go to infinity. So the problem in this case is with the series is that so often it's hard to calculate or compute exactly the value of the series, or where the series is going. And then our question could be, does it does this exist or does this not exist? Does the sum of the series exist or does it not exist? In other words, is the series convergent or is the series not convergent? So even if it is convergent, we may not always be able to find that where it is going or what is the value of the series. So we are now going to look at different types of series. So the first one is geometric series. Maybe you are familiar with this. Might have seen it somewhere before in your high school. If not, that is fine. Now the general form of geometric series is something we write like this, or we can write it like this. So notice here that the value, the power on r in the first case is n, and the power on r in the second case is n minus 1. So in the first case, this n is starting at 0. In the second case, n is starting at 1. In both cases, if you expand it, what you are going to get is a plus ar plus ar square plus ar cube plus dot 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 and so on. Well, a is the first term here, and notice that a has not to be 0, because if a is 0, everything is 0, then the sum of the series is 0. So a is some non-zero term, and it is the first term, because you see the first term is just a here. And what is r? R is the ratio of successive terms. So if you take the second term and divide it by the first term, you get r. If you take the third term, which is ar squared, and divide it by the second term, you get r, and so on. So if you take n plus 1th term and divided it by the nth term, you will see that you end up getting r. So r is called the ratio. So looking at this one example, if you have 3 plus 3 over 4 plus 3 over 16 plus 3 over 64 plus dot dot dot, notice that this can be written as in this compact form like this: summation n is equal to 0 to infinity 3 times 1 over 4 raised to the power n, where a is 3 and r is 1 over 4. So this is what a geometric series is going to look like. So if you're given something like this, you should be able to see it as a geometric series and then be able to write it in the compact form like that. And of course you are able to see the a and the r from here. You don't have to find it after writing it like this. So easily you can see the first term is a, and you can find the ratio of the second term divided by the first term. So you'll see you get 1/4. So let's try to see how when can we say that this geometric series converges. So what we do is we look at the finite sum, and remember that's what we explained in early in this case, that what we do, we find the finite sum and then we apply the limit to the finite sum. So we are going to look at Sn, S sub n, so which will be a plus ar plus ar squared plus dot 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 plus ar to the n. This is a trick that we use. So we multiply both sides by r. And so on the left side we get r times S sub n. So on the right hand side we get a times r. So notice what I did, I shifted the sum a little bit to the right just to see that the similar terms come under each other. Okay. So the only difference is now the last term is a and r to the n plus 1, but the term previous to this will be a r to the n. So now we subtract the two terms. So we subtract the second line from the first line. So the first line, on the left side we have Sn minus r sub s sub n equals. Now notice here when we subtract, these terms will go away. They will cancel out. So the only term which will be left will be the first from the first line and the last from the second line. So a minus a r to the n plus 1. Factor out S sub n here, factor out a on the right and divide, and we get S sub n equals this quantity. Now if our r is between -1 and 1, which can also be, statement can be written like this, absolute value of r is less than 1, then limit of S sub n as n goes to infinity, which is I explained here, which will become, so this thing will become 0. And why? Well, this is again something you should know, that if your r is, for example, if your r is a number 0.01 and you are raising it to a very big number, so what will happen? This will go to 0. And same thing will happen if you have a negative 0.01. So that our limit comes out to be a over r1 minus r. So now we say that a geometric series, which is looking something like this, is convergent if the absolute value of r is less than 1 and the sum will be equal to a over 1 minus r. So this is the easiest one. Also note that if the absolute value of r is greater than or equal to 1, then the series is divergent. Looking at some examples here, so it says determine whether the series is convergent or divergent, and if it is convergent, find its sum. Okay, so we look at the first one. Okay, so this is basically the first type of series that we are looking at, and which is the geometric series. So when you are given a series, the first thing that you should try to see, is it a geometric series? Can I write it as a geometric series? If yes, then you know how to find the sum or how to find whether the series is convergent or divergent. So we notice here that a is, first term is 5, second term, so you can say a1 is 5, a2 is negative 10 over 3, a3 is 20 over 9, and so on. So what if we take the ratio? So what about a2 over a1? So when I do a2 over 1, I'm getting 10, negative 10 over 3 divided by 5, which converts to multiplied by 1 over 5, which is giving me minus 2 over 3. When I do a 3 over a 2, 20 over 9 divided by 10 over 3 with a negative sign, and you can see that you get negative 2 over 3 and so on. And you notice that this is happening with every term. You can also see it by actually factoring out the 5, and you get 1 minus 2 over 3 plus 4 over 9 minus 8 over 27 and so on, which can be actually written as 1 minus 2 over 3 plus 2 over 3 whole squared minus 2 over 3 whole cubed and dot dot dot. So notice here that this is actually looking like a geometric series with A equals 5 and R equals 2 over 3. Actually negative 2 over 3. Okay. So notice here the absolute value of R will be absolute value of negative 2/3, which means 2/3 and which is less than 1. So which means series is convergent. Okay. So what is the sum of the series? So sum is equal to, or you can say summation A R to the n. So this will be equal to A over 1 minus R. So what is A? A is 5 and the R is negative 2/3, so it will be 1 minus negative 2/3 or 5 over 1 plus 2/3 or 5 over 5/3 or 3. So that is how you will find the sum of the series. Okay, so the next example is given a little bit compact form. So we first try to see, expand the terms and try to see if it can be written as a geometric series. So when n is 1, so we'll get 2 raised to the power 2 times 3 raised to the power 0 plus n is 2, so we get 2 to the 4th, 3 to the negative 1 plus 2 to the 8, actually 2 to the 6 and 3 to the negative 2 and so on. So which means you can write it as 2 square plus 2 to the 4 over 3 plus 2 to the 6 over 3 squared plus so on. And you can see here now, so you have 2 squared, so you can say 2 squared plus 2 squared into 2 squared over 3 plus, now this term 2 square into 2 to the 4 over, or you can say 2 square over 3 whole squared plus dot dot dot. So your A is 2 squared and your R is 2 squared over 3, which means 4 over 3, and you notice that this is greater than 1. So this is geometric series but diverges because R is greater than 1. Okay, next example we have summation n is equal to 0 to infinity. So if you notice, this is actually what is it, x to the 0, which is 1, plus x to the 1, which is x, plus x squared plus dot 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 and so on. And we are already given that the x is absolute value of x is less than 1. So this is actually a geometric series with A equals to 1 and your R equals x. So since this r, absolute value of r, which is equal to absolute value of x, is less than 1, so this means this converges. The series is convergent. So now we want to find the sum of the series or the value of the series, or so what will this be? So this will be equal to a over 1 minus r, which means 1 over 1 minus x. This is how you find the sum of the geometric series if it is convergent.